What we're going to do with these graphs are all changes with the square root of x. And square root of x is one of the graphs that we did at the beginning. So what we're going to do, starting with the first graph, is we're going to look at what happens to the points that they have on here, and how does that number, in this case, the 3 in the blue one, the 2 in the green one, and so on, how does that number in front of the square root of x affect the graph? So we start off with the point 16, 4. And if we look, where does that go? On the blue graph, we've got the point 16, 12. So we notice that one thing has changed, the y-coordinate has changed. It's gone from 4 to 12. How would you describe that change? Well, there's a bunch of different ways mathematically that you could get from 4 to 12. You could add 8, you could multiply by 3, you could probably figure out some very complicated equation to start at 4 and get to 12. But in this case, what we want to notice is we have a 3 outside of the function. We've learned when things are outside of the function, they affect what? The x or the y? The y. So all of the stuff that's happened outside of the function, remember we have a plus 3 outside of the function, that moved it up and down. Okay? Now we have a multiplication of 3 outside the function, and sure enough it's affecting the y value, and that y value is getting multiplied by 3. So just like the up and down was exactly how you would think, having a 3 outside of the function, what it's going to do is it's going to multiply your y values by 3. You might have noticed that with your parabola. You know, usually on a parabola you go over 1, up 1, but if there's a 2 out in front, you went over 1, up 2, and you doubled that. You multiplied by 2. So if we look at the other color-coded ones, we've got 16, 4, and on the green one, what's going to happen? You have 16, 8, and we notice there that the y value has been multiplied by 2. In our next one, 16, 4, in the orange one, where is that point on our graph? It is at 16, 2. That half in front, sure enough, you've multiplied your y value by a half. And finally, in the last one, in the purple one, that 1/4 out in front, so notice I'm talking about this 1/4 right here, that's multiplying your y value by 1/4. So having a number outside of a function affects the y value, and we call these vertical stretches and vertical compressions. We call it a stretch when it's stretched away from the x-axis, and a compression if you would have your hands above and below the x-axis and squish it down. That's what happens in the orange and the purple one. Oops. Everybody got this already? I'm just going to make it a little smaller. So you can, if you want to, you can still read it later. Right, but it's just there. Now we're going to look at what happens when there's a value inside the function. So notice in the second graph, all of the values are inside the function. So again, we're going to look at what is the starting point on the parent graph. The regular graph, y equals the square root of x. They've labeled one point. They've labeled 4, 2 right here. And on the blue graph, we now have the point 1, 2, because the bottom is going by 2's. What's changing now? The x-coordinate. And how has it been changed? Well, we've gone from 4 to 1. So you can either say that the x value has been divided by 4, But we're going to use multiplication again, and we're going to say x has been multiplied by 1 over 4. So just like the left and the right when it was inside the function was sort of opposite of what you thought, we're going to learn that for stretches and compressions horizontally, if it's inside the function, it's opposite of what you see. You see a 4, and you're going to have to multiply by, you remember what that's called when you flip it? The reciprocal. So we're going to multiply by 1/4. Sure enough, in the green one, if we have 4, 2, and we look at the green one, on the green one we have the point 2, 2. There's a 2 inside the green function, and we're multiplying by a half. On the orange one, we have the point 8, 2. There's a half inside that function. The reciprocal of a half would be 2 over 1. And so now our x values are getting multiplied by 2. And finally, in the purple one, our point 4, 2. That 1/4 inside means that we're going to multiply our x coordinate by 4. So horizontally we say the same thing. When things get pulled away from the y-axis, you can kind of think like an accordion. If you pull out, that's a horizontal stretch. And if you squish things in towards the y-axis, that would be a horizontal compression. So the blue graph is an example of a horizontal compression because the red graph gets squished towards the y-axis. Make those ones small. It's too big. There we go. And finally, with the last one, what happens if both of those things are together? So now, again, we're starting off with the starting point on the red graph is 4, 2. And here we have two things. We have, in the blue graph, we have y equals 4 times the square root of 2x. So we have a 4 outside of the function and a 2 inside of the function. So with anything outside of the function, that's always going to affect y. And anything outside of the function is sort of how your gut feels. So you're going to multiply y by 4 because you see that 4 outside of the function. Anything inside of the function, that's where the 2 is, that's going to affect your x values. And everything inside of your function is kind of opposite of what you would think. So here, instead of multiplying x by 2, you're going to do the reciprocal, and your x values are going to get multiplied by half. And sure enough, if we look at the blue point and where it's labeled, the x value has been multiplied by half to give you 2. The y value is multiplied by 4, and you have the point 2, 8 on your blue graph. On the green graph, 2 outside the function, right? That's going to multiply y by 2. The 2 on the inside of the function is going to multiply your x values by a half. And so your point on your green graph is 2, 4. On the orange graph, you've got a 2 on the outside of the function. That is going to multiply your y values by 2. And you have a half on the inside of the function. That is going to multiply your x values also by 2, because the reciprocal of a half is 2. So multiplying both of those coordinates by 2 will get you 8, 4. And finally, for the last one, on the purple graph, we've got a half on the outside of the function. So that means our y values are going to get multiplied by half. We have a half on the inside of the function. So our x values are going to get multiplied by 2. And we will end up with the point 8, 1. These things are called stretches and compressions, and we're going to add them to our translations. So far we've learned translations, moving things left and right, reflections, when you flip it over the x-axis, when you flip it over the y-axis, and now we're looking at how do numbers outside of the function or inside of the function, when they're multiplied, how do they affect the graph? And that makes them stretch either horizontally or vertically.